Hi, my name's Hayden. My cameraman today is Braden.
Hello.
Today we're looking at a 2006 Toyota Corolla. We'll start out with looking under the hood, and then we'll move to inside the vehicle. Alright, in terms of component identification, you have your O2 sensor that's before the cat right there. You have your 4 coil packs on top of the plugs. And then up front here you have your 4 injector connections. Then down here you have your camshaft sensor, the crank position sensors back here. You have an oil pressure sensor down below. You have your throttle body with the connection for that on the back side. You have your air intake temp sensor and mass airflow sensor built into one sensor here. There's a knock sensor down in the center behind the intake manifold. I'll try and get a picture of that for you. The engine coolant temp sensors down here on the side of the block. I think that's most of the major sensors. Alright, so I found that there's 2 fuses for the EFI circuit. You have this fuse 20 here, which goes straight into the ECM and is also the always on circuit for the ECM. And then you have a secondary 15 amp fuse that controls the power to all the other circuits that are connected to the EFI system. This circuit's only powered when the key is in the on position, and it's controlled through this relay here. So if I test, you'll see that there is 12 volts even with the key off. And if I test this one here, there's no voltage. Okay, Braden, go ahead and flip the key. But with the key on, the relay closes, and I now have voltage at this secondary fuse because now the system is powered. Taking a look here at the wiring diagram, you can see the EFI circuit over here. So you can see this is battery positive, and it comes in and is powering the ECM at all times. And this is that 20 amp fuse that's always hot. Then it runs over here to the relay that I had mentioned. And then when this relay is closed, which is controlled by the ECM, when this relay is closed, it comes over and powers this fuse, which then runs all over the place and powers a bunch of the other sensors related to the EFI system. Taking a look at our data link connector here, there's only a few pins that are actually in this car. The first of them being chassis ground on pin number 4. Number 5 is signal ground. Number 7 is bus positive lane. This is a communication with the ECM. 13 is TC, which is timing check, which is related to the ignition timing system. 15 is WFSE, or ISO 9141-2, which is another communication with the ECM. And then pin number 16 is battery positive. So checking the first one, we have 0 volts, which means that the ground is there, and 0. And then pin number 7, we have 9.67 volts. And then pin number 13, we have 9.86 volts. Pin number 15, we also have 9.53. And then pin 16 is battery positive, so we have 10.59 volts currently.
Alright, so the scan tool is installed on the vehicle. Here you have automatic ID or manual ID for selecting the vehicle's VIN number. So we're going to go through with automatic. Alright, so you can see the scanner has identified the vehicle, the VIN number. That is a 2006 Toyota Corolla with the 1.8 liter in it. Alright, if we go to engine, automatic transmission, and here you can see We can clear the codes here and clear the memory of the vehicle. And here's a live data display, which all displays the PIDs. So we go into that. All right, so we can look at the engine data, misfire data, sensor data, or other data with the vehicle. If we go into engine data, all right, so here we can see the engine speed, any malfunction indicator light, if it's on, fuel system, coolant temperature, the short-term fuel trim of the vehicle, long-term fuel trim, vehicle speed if we were driving the vehicle currently, ignition advance, air intake temperature, MAF. And let's start the vehicle, get ourselves some live data. Alright, as you can see right down here, we are currently at 1100 RPMs. Then our coolant temperature is at 136. Short-term fuel trim is changing constantly as it's updating. Our long-term fuel trim has changed a little bit as well. Alright, so for sensor live data, we chose our MAF sensor, and as you can see here, the value of the sensor is constantly changing. So for experimentation purposes, we're going to unplug this sensor and see what happens to the vehicle when that sensor is unplugged. As you can see now, the sensor has just been unplugged. Alright, after we unplugged the MAF sensor, it looks like we had a powertrain code pop up, P0102, MAF circuit low input fault, which a sensor is an input, so when we unplugged that sensor, the circuit lost its input and therefore shut off the vehicle.